My dear students, today I am going to explain work energy power related. This is also high weightage chapter for NEET and KSET. Very important students. Work energy power. Please concentrate each and every problem. Now here very first question. The linear momentum of the system is conserved in students. Collisions related question. Whether it is elastic collision, inelastic collision, perfect elastic collision, perfect inelastic collision, one-dimensional collision, two-dimensional collision, whatever collisions related, one physical quantity must be conserved, that is linear momentum. So in case of elastic collision, momentum as well as kinetic energy both conserved. In case of inelastic collision, only momentum is conserved, kinetic energy not conserved. Now here elastic only, inelastic only, not only elastic, inelastic, both elastic and inelastic. So very first question, easy question students. Linear momentum conserved, both elastic and inelastic collisions. Next question students. Conical pendulum of length is L makes an angle theta with respect to z axis, given diagram, and moves in a circle in xy plane. Radius of the circle is r and its center vertically below the point P as shown in diagram. Okay. The speed of the pendulum in circular path. Listen students. So at this position, how many forces acting on pendulum bob is? Weight mg acting vertically downward direction. Tensional force T is acting this direction. So here angle theta means with respect to vertical, here also angle theta students. You know very well. So T resolved into two components. Horizontal component T cos theta. Vertical component is T sin theta. T sin theta. This component is T sin theta. Now circular motion students. So now here centripetal force acts towards the center. Centrifugal force acts away from the center. Inertial frame, centrifugal force acts away from the center. Centrifugal force is mv square by r students. Mv square by radius is r. So there are four forces is acting at this position. The speed of the pendulum, here it is asking. Just equilibrium condition at this point. T sin theta. Equilibrium condition T sin theta. From the diagram, T sin theta equal to mv square by r. T cos theta. T cos theta equal to mg. So let us consider this equation 1, this is equation 2. From equation 1 and 2, divided 1 and 2, tan theta equal to, yes, you know very well, m is cancelled, v square by r into g. V square equal to from here r g tan theta, v equal to from here under root of r g tan theta. Very important students. Formula based questions also sometime they will ask. So what is velocity, what is the speed of the pendulum at that point is root of r g tan theta. Second option correct students. Next students, it is very important. Now next question. Potential energy U of a particle plotted against its position x origin, the equilibrium position, equilibrium condition, force, potential energy and displacement position vector, force relation students. Conservative force Fc equal to negative potential energy gradient du by dx, negative potential energy gradient. Now question asking, equilibrium condition is nothing but, you know very well, net force equilibrium condition, net force F net equal to 0. So equilibrium condition force equal to 0 means must be du by dx slope 0 students. Now x1 here slope not 0, slope is positive. x3 here also slope is not 0 students, negative. But at this point x2 you see here tangent. So tangent here tan theta, slope 0 students. Tan 0, So slope 0. Slope 0 at what point is nothing but, yes, x equal to x2, slope is 0, force is 0. It is conceptual question only, it is important, students. So force, conservative force, Fc equal to, just remember, minus negative potential energy gradient, minus du by dx, du by dr, position vector. Okay, students. Next, a block of mass m, mass 3 kg, connected to a spring while spring is relaxed state. Listen careful, students. This model question is important for objective. Now if the block is released, then maximum extension of the spring. Just listen. If block is pulled downward, students, so block is pulled downward. Now here block at this position. Many students confusion, this is not extreme position, actually this is mean position. So if it is displaced, means it is moving to and fro motion about a fixed point. Here it is mean position. This is extreme position, mean position and extreme position. It is oscillating from mean position. Yes. Now extension of the spring here, x naught. What is extension of the spring is nothing but, you know very well. Now here weight mg equal to, general expression, students, weight mg equal to restoring force developed in the spring is k into x naught. So x naught equal to, from here, mg by k. This x naught is elongation, extension of the spring. But read careful question, students. Maximum extension of the spring asking. So here x naught, this side also x naught. What is maximum extension is nothing but, it is not only x naught, 2x naught, students. Maximum extension of the spring is 2x naught. So from here, students, just multiply both sides to 2x naught equal to 2 mg by k. Just multiplied with 2 both sides. Values given, just values substitute, students. 2 into mass of the block is given 3 kg, acceleration due to gravity 10, and k also given here 1000. Right, k is 1000 is given. Now this 0 is cancelled. So 6 by 100 meters, students. 6 by 100 or 6 centimeters. So 100 take out, take up 10 to the power of minus 2. 6 into 10 power minus 2 is 6 centimeters. So option 3 is correct. Listen, students, many students confusion here. Extension of the spring means only mg by k. If you substitute 3 centimeter also given. Maximum extension, only extension different. Extension same question means only 3 centimeter. Maximum extension of the spring is nothing but 6 centimeters, 2x naught. This point remember, students. Please note this point, very important. See, whenever I am stretching, students, these model questions only, these points only very important. Whenever I am stretching, please note that points very important. Maximum extension here it is 2x naught. Yes, I think clear everyone. Next questions little easy only, students, you know very well. So A vector given, B vector given, then dot product of both vectors equal to, dot product A bar dot B bar, you know very well, I component multiplied with I component, 3 into 1 3 plus 4 into 2 8. So 3 plus 8 11. So 11 units is answer for this question. 11 unit, second option. It is easy, students. Dot product, I think 99% everyone you know dot product. Next, statement A, ability to do work is called energy. Yes, students. Energy and power is scalar quantity. Work, energy, power, all scalar quantity, students. This is also correct. So statement A and statement B, both statements are correct. I think this is also easy question, students. These two questions easy. Next question, students, vertical circular motion. Please concentrate. This concept also very important. This question, vertical circular motion related question. Now question, a bob of pendulum rest is given horizontal velocity under root of 7gl. That means lower point velocity is given root 7gl, where L is length of the string. Vertical circular motion. Here length is L, means here lower at this point velocity is given root 7gl. Okay. So now question is asking the tension when Bob will reach highest point of circular motion. At this point, what is the tension asking students? So what is the tension at highest point? Listen, just two formulas students. Vertical circular motion, for example angle theta. What is speed vertical circular motion at this point? Means velocity theta angle v theta equal to under root of, for example here velocity v1 means general expression v1 square minus 2g r is nothing but here l, 2gl into 1 minus cos theta. This is expression for speed or velocity at any instant, here, wherever you consider. Speed at any instant v theta equal to under root of v1 square minus 2gl into 1 minus cos theta. Yes, what is the tension at any instant? Tensional force T theta equal to mv theta square by r plus mg cos theta. This is expression for tension at any instant students. Please remember vertical circular motion, these two formulas, very very important. Now here velocity 180 degrees highest point. Here what is velocity? Velocity highest point vh equal to under root of v1 square. Here v1 square is 7gl minus 2gl into highest point 1 minus cos theta, 1 minus cos 180. Highest point angle is what? With respect to here 180 degrees. So cos 180 value is minus 1. So answer here it is velocity at highest point is root 7gl minus, here it is 2gl into 2 4gl. That means under root of 3gl is velocity highest point. Now tension at highest point asking question. Tension at highest point th equal to m into this one students, v theta square means v180. v180 highest point is how much? 3gl by r is nothing but l. Highest point cos theta equal to 180. So that means here minus mg. So this l is cancelled. 3mg minus mg, 3mg minus mg, 2mg option 1, first option given students. Please concentrate. Vertical circular motion, any problem, velocity at any instant, remember. Tension at any instant, remember. Here tension at highest point, how to calculate I explained, given question. Sometimes tension at horizontal position, here what is the tension, like that questions. 60 degrees what is the tension, 120 degrees what is the tension, like that questions. Any question like this, please concentrate students. Please remember, very very important concept. Okay, now here first option 2mg is correct. I think this problem everyone clear. Next one students. Next little easy only. A constant force applied on 10 kg mass at rest. Ratio of work done. Constant force students. Work done W equal to, you know very well, work done W equal to force into displacement. Force constant only. Displacement first second, displacement second, displacement third second. You know displacements ratios, s1 is to s2 is to s3. Displacements first second, third second, 1 is to 3 is to 5. So displacements 1 is to 3 is to 5 means work done also first second, third second, 1 is to 3 is to 5. So now here second option is correct students. Force is constant only. Displacements ratio 1 is to 2 is to 5. Work done ratio also, ratio of work done also 1 is to 3 is to 5. Yes, it is easy problem only students. Next question. Concept like above only, that's why here listen careful. Question here. Particle of mass m tied to a string of length is L, given circular motion, vertical circular motion. If it performs the complete loop, then difference in tensions at lowest point and highest point. Tension lowest point and highest point. condition for completing circular motion, minimum velocity at lowest point is root 5gr. Minimum velocity is greater than root 5gr, it is completing vertical circular motion, minimum root 5gr. Yes. Now at this point tension maximum, students, vertical circular motion, here tension is minimum root 5gr or root 5gl is nothing but here tensional force is 0 only, students. Very important. Vertical circular motion, minimum tension at highest point, tensional force, tension is 0 but velocity not 0, students. Very important. Vertical circular motion, topmost point, highest point, velocity not equal to 0 but tension equal to 0. Yes, first what is the tension at lowest point is, tension at lowest point is maximum mv1 square by r plus mg. This is expression for tension at lowest point. Minimum condition v1 is nothing but 5gr. So now here m into root 5gr whole square means 5gr by r plus mg. Now here r is cancelled, 6 mg. Tension lowest point is 6 mg. Tension highest point I told 0, students. What is the difference in tensions asking? So 6 mg minus 0 is nothing but 6 mg only. Option 4 is correct. So tension, vertical circular motion, where it is maximum is lowest point, where it is minimum is nothing but highest point. Minimum tension, condition for looping a circle, vertical circular, velocity highest point not equal to 0, velocity minimum is root gr and tension highest point equal to 0, students. Yes, I think this problem everyone clear. Very important. Vertical circular motion, 2 questions I explained here. Same model questions. Final exam also they will ask. Next, students. Particle of mass is m is projected with an initial velocity u at an angle theta with horizontal direction. Work done by gravity during time it reaches its highest point. Important question, students. Now projectile motion. Particle is projected making an angle theta. Path of projectile is parabola. You know very well. Particle is projected with initial velocity u making an angle theta. Highest point. Particle is projected vertically upward means displacement is upward direction. Highest point here, force, acceleration downwards. Force also downwards here. Force is mg. So maximum highest point force is mg, downward direction, and displacement is upward direction. So force displacement opposite direction means work done by that force is negative. I think you know very well. Work done W equal to F S cos 180. Cos 180 value is minus 1. Work done W equal to minus F into S. Yes. Work done W equal to minus mg S. What is S is nothing but at this point what is S means maximum height only, students. Projectile motion, what is expression for maximum height? You know very well. U square sin square theta by 2g. This is maximum height formula. So now here this is only I think option is given. Now half m u square sin square theta. So this g is cancelled, students. Minus half m u square sin square theta. This is only work done given third option, students. Minus half m u square sin square theta. Clear, students? Plus also given, students. Very important. Plus also given. But here maximum height, force downward direction. Particle is projected vertically upward. Displacement is upward direction and force is downward direction. Force displacement opposite direction. Work done by that force is negative. Plus also given. Please see careful options. Yes, students. Next question. A particle is in conservative field whose potential energy varies with position. I think above one problem I explained. Conservative force equal to minus negative potential gradient du by dx. Now question. Net force on particle is 0. Where particle force 0 means slope must be 0. OA, OA here slope not 0 students, theta is not 0. BC also theta not 0, here theta slope is negative, more than 90 degrees, less than 90 degrees. AB part here you see with respect to horizontal theta equal to 0. That means AB part force is 0. Differentiation here, AB part force is 0. So now force is 0, A to B, second option is correct. Clear students? So thank you students, thank you. Continuation, next problems, one more video I'll explain. Students, if you like this video, please subscribe students. Okay, thank you students, thank you.